First of all, thanks for inviting me for this conference, and it's my pleasure to give a small update on, what are the new technologies or digital engineering in terms of simulations. Okay, can you go to the first slide, please? Oh, I can go. Yeah. So I come from a company called CADFEM, and I think the name itself says much about digitalization, right? So it's the CAD, which is a virtual designing of yours, and there's the FEM, which is a virtual simulation of your products. How many of you are doing a product development using simulations here? Okay, only 3 hands I see. Okay. I think we'll see why it is so important for MSMEs, to do a simulation-driven product development. And we also talk about a digital engineering in a very broader sense, not only just in terms of product development, starting from the conceptual phase to the in-product phase, where we are talking about ADAS, digital twins, and other things. Okay. So, just a brief intro of our company. CADFEM is basically a global company, which is our parent company is in Germany, and in India we started in 2007. So what we are majorly into is, we actually are one of the largest producers of simulation technologies in the world. Okay. Along with it, we also kind of have 40 years of experience in terms of rapid product development and also innovating for a lot of our customers. Especially we deal with a lot of MSMEs in both India as well as Germany, Southeast Asia, and all other countries. And also we deal with a lot of bigger customers, starting with like Bosch or, let's say Grundfos and other companies too. Okay. And the major advantage what we have as a company, a group is because of a global presence, we could develop an expertise in different physics, because simulations, when you talk about it, or digital engineering, when you talk about it, it's no more one single engineering or one single physics for that sake. So we have a vast range of physics which we are dealing with, starting with the structures. We talk about CFD, we talk about electromagnetics part of it, both high frequency, low frequency. Like low frequency, when I talk about like motors and all, when I talk about high frequency, I'm talking about PCB boards, radars, and then we are talking about optics, where you are talking about LiDARs, laser weapons or optics lenses and everything, right? And then we're talking about embedded systems and also the functional safety and cyber security of your products. That's becoming very much important nowadays, because of a lot of OEMs are asking for to make sure that your product is, because you have a software and it should not be hacked, right? So the cyber security becomes very, very important for all your products when you are offering it to your customers, right? So all this comes into picture, and those all things we can simulate and test and virtually test them and get a much more insight into all of this. So about us in India, I think as I said, we started in 2007. Our parent company is in Hyderabad. It's hardly a few hundred meters from here. But we also have offices wide across India in 7 different locations: Bangalore, Chennai, Pune, Delhi, Coimbatore, and Ahmedabad. Okay. So we have a wide range of expertise. So we deal with, in India itself, we have around 300 plus customers, and majority of them are MSMEs. Okay. So for us, digital engineering is very, very important. So we start with the centric of customer, where customer wants to innovate, make their products more efficient, and also reduce the cost of their products, right? So when that is what they want to do, the first thing what they want to do is how to adopt the simulation. Okay, that's the first step. How can they use simulations to drive their innovation or drive their product? Second thing is to automate the simulation itself, so that you can democratize it across the users, and you can make it much more user friendly, because doing simulation is one front, and making user friendly and because a lot of people are talking about the skill gaps and all, right? So to overcome that, we can also automate it and actually make it much more button click solutions, where you can do your simulation, especially when I'm talking about sectors like non-engineering, I mean to say non-traditional engineering sectors like pharma, where they are using simulations nowadays. They want to go in silico instead of in vivo and in vitro, right? So when you're talking about in silico, that is something which they are adopting nowadays, and they want to do simulations upfront to understand how the mixing is happening, how you manufacture, how your stunts you are manufacturing are going to work, what's the life of those stunts, or if you are doing a hip implants, you want to have a customer-centric data, which is very specific to each and every customer. You get the scan data, and based on the scan data, you want to actually do an implant using additive manufacturing or the different manufacturing techniques, right? So when these people who are coming from other backgrounds wants to do simulations, the automations become very, very, very important. And then over that, the top circle really talks about the digital engineering part of it, where we offer services to customer, because selling a software or offering a software to the customer is not the end thing, right? That will not lead to the success for the customer. So it becomes very important for us to integrate the software solutions along with the services, along with the knowledge transfer and the training sessions and everything. So that is where we really built on IT infrastructure. So we offer the hardware to the customer, which is very simulation centric. I'm not talking about just the IT hardware, but for simulation itself, we need to customize the hardware so that it can run very efficiently. Then we are talking about the knowledge, what they have to build. The major challenge what you're facing nowadays is to get the core engineers, because a lot of colleges are dropping the core engineering courses out of their curriculums, and it's becoming very problematic to get skilled engineers for your simulation purpose. And that's what we want to also bridge a gap. Okay, so today's topic, we majorly talk about the digital engineering part of our MSMEs, and this is very, very important because the MSMEs are a key lever for the India 5 million economy, right? So we are the 30% contributor for our GDP, and 42% of our exports, right? That's what people were talking this morning, and that is very important to concentrate upon this sector and how we can enable the MSME sector to kind of adopt that digital engineering for them. Okay, so the main challenges is for all the industry sectors is to drive the innovation, complexities, because you're not dealing with one single physics now. You have the interconnectivity between different things, and now you're talking about industry 4.0, where you are talking about automation, where we have a lot of sensor data coming in. You have a lot of lens, LiDAR is there because the camera has to see it, get the data, and based on the data, let's say you have an ADAS system. Based on the LiDAR in your car, your autonomous vehicle has to perform. If a person comes in front of you, based on the LiDAR sensor, it has to take the signal, capture it, and based on that, it has to apply a certain force on your brake so that it stops at a safe distance from the person, right? So this all becomes very complex, and we are really talking about connections between different systems and different physics here. That has become a huge problem. Then the cycle time. With so much of innovation going on, so much of competition, the cycle time to the market has come down drastically. Previously, maybe people used to take maybe 8 years, 5 years to develop a car to come out. Now they're coming down to 3 years to develop a car and coming out into the market, right? So thus times are coming down drastically, and the innovation and the complexity is going up. Okay, so right now in the industry, there are two interesting things happening. One is the technology is really helping you to reduce the development time. The second thing is the destructive part of it. The simulation, the technologies are becoming so advanced. Your present models, present things are becoming obsolete, right? It's no more makes sense. So when you want to really talk about leveraging the advanced technology which is developing day in and day out, and to leverage your legacy technology, for them to have a proper marriage between them, you need to have a digital engineering. Otherwise, there's no other way you can take it for, right? So to actually reduce the cost, increase the quality, and evaluate the risk, we need the simulations, and there's no other way to move forward. Okay, so this is one of the survey which happened in US. So they want to see, with simulations and without simulations, what is the difference, and you can clearly see 21% improvement with simulations to to launch that time to market. 22% they could meet the targets. 17% increase in the quality also. So these are the important driving factors for any MSME, right? So these are three things what you want to look at and make sure that your product is coming out in market in a given time frame, and you are also with a low cost. So how do we get it right in the first, early itself? That is very important because most of your cost is decided in the initial phase itself, before even you start simulation, where in the conceptual phase you have something, and like 85% of your cost is decided in the initial phases. So if you want to make some changes, the influence of these changes will be much less in the later stages. But in the early stages, if you want to make some changes, you have much scope and you can improve it, and the effect of it is much more wider reach. Okay? And with the traditional techniques where you are pushing your design to the end and doing a prototyping and going for testing, and if something is not working, coming back, this is going to take a lot of time and a lot of cycles, right? So what you want to do is you want to implement the simulations in the first phase itself so that you can understand your product much better, optimize it, innovate it, and then you can reduce the cost and everything. And then once you finalize your design, then you can go for your prototyping, which when you are much more confident that it's going to pass and go forward, right? Nowadays simulations are becoming so realistic that people want to reduce testing drastically, just to one test, maybe two tests at the end of it. But most of the times they want to avoid the completely and take simulation as a benchmark. And I think a lot of the defense sectors are also asking their suppliers to submit the simulation remotes, right? That is becoming much more important nowadays. And I think a lot of the OEMs, automotive OEMs, aerospace OEMs are also asking you for these reports to be submitted so that, you can make sure that your product is compliance to their requirement and everything. Okay, so that is what I was talking about, the virtual prototyping and simulation-based product development. Okay, so there are 3 important technologies out of the 10 for digital engineering which are actually disrupting or help the industry to move forward. I think the first one is the AI ML. That is something one of the dignitaries is going to talk about it in the next session. But the next one is additive manufacturing. I think this is one of the technologies a lot of people are using nowadays to do the prototyping or also taking it to the next level of mass production, So the reason why additive manufacturing has become more popular is because it can manufacture any kind of complex shapes, and you can actually make lightweighting much more possible, right? But it has its own problems. I think this is not a platform to discuss about it. We can take it later. And the third one is the simulation front, where you can see a lot of people are saying the simulation is very, very important, right? So I think let's see how the simulations develop. I think in 1970s, simulation was only for academics. They were doing a lot of research and they were developing. That's fine. Next 85 to 2000, having no simulation, it's still okay. It's normal. A lot of people are not doing simulations. In 2000 to 2015, simulation has become a normal. A lot of people started using simulation. It's still not a compulsion, but still a lot of people have started doing it. As you can see the examples here, you can see it in the optics field, you can see it in the sensor field, you can see in amphibian mobility services here, oil and gas, other sectors where simulations were not traditionally used. It has moved into that. In 2015 to 20, no simulation is not normal. So people felt that, okay, you're not doing simulation still, you should start doing it now. I think as you can see, the technology of IoTs, 5Gs, electrification, ADAS and all actually has pushed simulations. As you can see here, we are doing a signal integrity problem here to generate what are the losses, what the temperature generated because of that, and then see the thermal and cooling part of it. And then we are talking about, because of the thermal cooling and all, how the soldering is working. And if these are failing, your component is going to fail, right? So you can see 3 different physics combined together, and you need simulations for that. Not only that, we are also talking about crosstalks between 2 different devices, because nowadays, IoTs have become so much. We have, Bluetooth everywhere right nowadays, right? So there should not be a cross connection between them, how they are kind of working. All these things can be tested in simulations. Okay, and e-mobility, I think this is where a huge chunk of MSME customers are supplying to this, where they're talking about motors, batteries, the charging systems, So the motors have become very important, and we have a lot of motor customers itself in India whom we are dealing with, who are using our softwares to develop their motors and innovate with respect to characteristics of the motor, including efficiency. The noise has become much more problematic because sustainability and environmental norms have become much more stringent nowadays, right? And the fatigue failure of it. The first thing is to get the efficiency map of the motor, for different frequency rotations and all. Then we are talking about the noise levels. When we are talking about different frequency with respect to different RPMs, where the noise levels are, how is it generated, and everything. So this, because all of our OEMs are actually concentrating on this and keep asking us how we can do NVS simulations for our motors and everything. The same thing with the chargers, the same thing with the batteries. The batteries are much more problematic because you have to do the thermal runoff tests, because a lot of blast, fire is going to happen because of batteries nowadays, and this is becoming more problematic, and the battery management system has become very complex, and that is very important to be handled. So you need to do a system simulations to understand that part of it, right? And you need to have an IoT platform to sense a lot of, if you are talking about Ola, Ether nowadays, you have a lot of performance monitoring systems where you can monitor how your battery is performing, how many kilometers it's going to give more, and a lot of other things, right? So this is where the technology is being driven to, and it can adopt it so that based on the performance of your batteries, it can automatically adopt and make sure that your battery efficiency is pushed forward, right, and make it more efficient and efficient. We are talking about the manufacturing sector, where you want to just manufacture this kind of structures, where you can go with additive manufacturing, where you can get this kind of complex shapes which can be manufactured with additive manufacturing like this, and we can see better, cheaper, and faster you can get it. With less volume and mass, you can increase your stiffness of your structures. That becomes very important. We are talking about medical. This is a very simple example where you have a, you want to have a kind of make sure that your teeth are properly aligned, and you go to a dentist, right? That becomes very important. Your space is not symmetric, but the loads they apply internally are symmetric. And they need to understand what forces should they apply so that your teeth are properly aligned, so that you don't have this distorted figure in your after the whole teeth are aligned properly, right? So this becomes very important to be tested. So you can do simulation for that front also, where you can take the customer specific data and do the simulations and understand what kind of force you have to apply and which positions you have to apply, so that you can get a proper jaw alignment, right? We are doing it for, we have our own wing of medical, for medicine. We do a lot of simulations for doctors, for, plastic surgeries and other surgeries, so that, people can use simulation for that front. Okay. And now in 2020s and moving forward, the simulation is becoming a must. As I said, a lot of customers are asking for it, OEMs are asking for it. Starting with a simple example like this bottles, it becomes very, very important. We have a huge customer whom we actually do a lot of simulations and a lot of automation for the bottle suppliers itself, where they want to see what is the buckling force, manufacturing of the bottle, sustainability of the bottle, environmental effect. They want to reduce the plastic usage. All these things are coming into picture. So you can see there is a structural problem, there is a molding problem, a manufacturing problem, there is a thermal, there is a cost influence. So you want to see different physics combined together. You can combine all them in a workflow and then do a simulations to understand what would be the best design, best settings of your manufacturing, so that your cost can be reduced starting from the material to the manufacturing itself. Okay. So with digital engineering, you can see the traditional technique, you take 50 months to develop your product, that can be got down to 36 months or even less as you move forward and make improvements in your processes. Okay. So with that, I'll come to the product side of it, where ANSYS is leading in this part of it. ANSYS is a tool what we are using in the background to do the simulations for each and every physics. ANSYS is leading in terms of every physics what you deal with, whether it's structures, electrical, CFD, optics, you name it. We are the leaders in all the physics, and we deal only with the simulations. We are not into any PLM or any CAD or anything. We purely do on the simulation. That is our core bread and butter, and that's where we concentrate upon. And as you can see, as you can see, we are dealing with the physics in the bottom. As you move up, it's becoming more and more complex. We are talking about system software. We are doing a system level simulations. Then we are talking about system of systems. This is where defense sector is talking about. Now they have a satellite, they have a radar, there is a flight, moving, or missile coming in, the projectile and all. So they want to have a communication between system of systems, and they want to actually simulate this kind of war scenario to see what is happening. Let's say there's a missile coming in, they want to shoot a laser to destroy it. right? So at what time they have to shoot it, and what, how much intensity they have to shoot so that the missile can be destroyed. All these things have to work together, the systems have to work together and can lead to this, right? So this becomes very important for us to take it to that level of it, and then you can see the solutions and the industries on the top of it. So traditionally we are talking about previously the simulations are only used in the design phase, optimization phase. That is fine, we are not using it in the requirements, concept, preliminary design or any other phases. But as we move forward, as the requirements move forward, it's becoming more and more complex, and we can't work anymore in silos, right? So we need to, when we are talking about interdependency on the different departments, and we have to can't move forward and backward, and we can't just maintain it over a paper and kind of communicate it over just the documents. We need to have a proper models which we can communicate within each stage and make it digital thread like this, which is much more convenient for the customers to develop it and move forward, right? So the first level is the virtual simulations, what we talk about. Then we are also actually moving to the next level, which is called digital engineering, where we have a lot of other things involved, not only just for the design phase itself, to the whole development phase, from the inception, product requirements to the end phase of it, So this is the V model, what we talk about the product development. So we have the, just to go back, we have the first one is the requirements, then we have the system, subsystem level, and then the bottom is where traditionally people used to use simulations, where it's the component level of it. But nowadays it's no more like that. We start with the requirements, we generate the models to the requirement. So we have the model based system starting from 1. So we have the models with the requirement level, we can take it to the system level, then get all your requirements for the system level and check them. Then go to the next level, which is a subsystem. Once you cross the subsystem, you go to the individual component level, where you work in the silos on different physics. Again, you integrate them in the subsystem level, validate it, take to the system level, integrate it with your software, everything, check whether it's compliant with your ISO standards and everything, and then you take it to the next level, which is again the system of system levels or digital twins in product. How many of you heard about digital twins? So I think it's a very fancy word people are talking about nowadays, the digital twin, and this, I can just tell you very simple, people can say digital twin as a CAD itself is a digital twin, because it's virtually representing something. It's called a digital twin of your design, right? Yeah, I'm done with it. So the next point is, I think it's very, that is something which people are getting confused with, but digital twin is much more broader in the sense where people want to do a predictive maintenance than go for a regular maintenance. And that is what we really talk about here. The simulations are no more used in only one phase, but you can use simulations in all the phases, starting with ideation, design, manufacturing, in product, in process, and everything. So where we are talking about ADAS, which is in your product, it is sitting. Simulation sitting in your product, based on the data you get, it reacts and applies a force on the brakes to stop the car. Digital twins are also sitting on your product to monitor your, as it goes, as your life of, like let's say I have a jet engine, I have to monitor my jet engine so that I should know when should I go for maintenance instead of doing for regular maintenance, which is more costly, and I don't know whether it's going to fail before the maintenance or after the maintenance, So all these things, right? So here is a transformation, what you can see in product, the CAD, I think a lot of people are doing. I think product development, we can do 3D printing, additive manufacturing, and simulations. Product testing, a lot of people are doing, especially for ADAS nowadays. People cannot do the field testing. They need so many years to actually drive so many miles to test the cars. What they're doing is everything virtually tested. They have, they have the VRs, ARs, and all these things, and using machine learning techniques to adopt and test it, and then they're coming out to market with ADAS 2, 3, 4, 5 levels, Okay, and the product maintenance, which I was talking about, digital twins, and the knowledge management is also there. So this is one last slide of mine, that is what we are talking about. So this is very important. We have our own courses, which is called AAC, ANSYS Innovative Courses, which help a lot of customers to adopt it. It's free. AAC is free. You can go through the courses. You can learn a lot of basics very easily and it's actually a tie-up with Cornell University in US and a lot of universities throughout the world. And these courses are generated and they're very user-friendly and easy to understand. Only if you want to buy badges or certification, that's when you have to pay, but the courses are free of cost. And there are we are also tied up with IIT Chennai called IIT Pravartak, where we do 5G courses. It's a paid course. You can attend for it. and then other courses also. Okay, so this is what I will end with. And this is what we all want to try and do it, right? The sustainability of your products, right? And have a environmental effects, social, consciousness. All this becomes very important. So you want to reduce your usage of material with a less amount of material. You want to make your products more and more efficient, and that's where only digital engineering can help you do this. Otherwise, it's highly impossible to stick to your deadlines, cost, and everything. It's not possible. I think with that, I will end my session. Thanks for your time. I think I can take the questions later on because of shortage of time.